This is the video on chemical reactions. So remember, in all of these videos, there are two codes. One will be a written code that'll be on the screen. The other code will be a verbal code said by myself. Each code will be 3 numbers, and you're going to need to know those codes in order to move on with the homework assignment. So when you are looking at these slides, and if you're taking notes, write what's in green. Those are the most important, like bullet points. The rest is just additional information that could help you out if you need if you're struggling with that. So this is the weekly. This is the written code. I would recommend you write this down somewhere. So this is the question. Well, what are the different types of chemical reactions? So this is the chemical reaction, the definition. A process in which one or more substances, those reactants, are rearranged to form one or more different substances, those products. Substances are either chemical elements or compounds. A chemical reaction rearranges the constituent atoms of the reactants to create different substances as products. You can see the different types of chemical reactions over here that we're going to go over. So the first type of reaction is a synthesis chemical reaction. In a synthesis reaction, 2 or more chemical species combine to form a more complex product. So this is that chemical reaction model. A plus B reacts and forms AB. What makes it a synthesis reaction is there's only one product. So the combination of iron and sulfur to form iron sulfide is an example of a synthesis reaction. And you can see that chemical equation down there. And you can see the chemical reaction model up here. A plus B reacts and forms AB. Now, the next type is a decomposition reaction. This is a compound is broken into smaller chemical species. So this is AB reacts A plus B. And you can see that reaction model up in the top right. And there's only one reactant. So this is the exact opposite of a synthesis reaction. So you can see up at the very top, AB reacts A plus B, and there's only one reactant, only one thing on the left side of that arrow. Now, the electrolysis of water into oxygen and hydrogen gas is an example of a decomposition reaction. So this is the chemical equation for that. I've got water, I run electricity through it, and it's going to break the hydrogen and the oxygen apart. Now, a single replacement reaction. Single replacement reaction is characterized by one element being replaced from a compound by another element. So this chemical reaction model doesn't quite match the one up here, but same idea, right? Essentially, just one element is being swapped out with the other one. There's an element on each side of the arrow. So if we look at the top right one, AB plus C, we'll notice it reacts and becomes AC plus B. A way to think about this is a sad one if this was a dance. A, B, and we're dancing together. This is C butting in, kicking B out, and B is all alone over there, right? So this is sort of just a way to envision it, right? And I have an element on each side of the arrow. An example of a single replacement reaction occurs when zinc combines with hydrochloric acid. The zinc replaces the hydrogen. So zinc reacts with the hydrochloric acid, zinc chloride, right, and the hydrogen. Double replacement. All right, so yep, and the hydrogen gas. All right, so now we have double replacement. Double replacement reaction, 2 compounds exchange bonds or ions in order to form different compounds. So AB plus CD reacts to form AD plus CB. So it's a partner swap. This is like if you're a dance, if it's a dance, notice AB are together, CD are together. Well, then they react. Now A and D are together, and C and B are together. So this one isn't that sad because you're just switching partners. An example of a double replacement reaction occurs between sodium chloride and silver nitrate to form sodium nitrate and silver chloride. So you can see that chemical equation there. Now, the last type of reaction is a combustion reaction. This is a special case, right? This is a sort of a special one, the odd one out. Sometimes it's not even taught with reactions. It's taught like separately. But a combustion reaction occurs when a fuel combines with oxygen to produce carbon dioxide, water, and heat. So this is the chemical reaction formula for it. Notice it doesn't have A, B, C, D. Essentially what it is, the most common type is a hydrocarbon. So like methane, like CH4, react with the oxygen in the air, the oxygen air, and they react to form carbon dioxide and water, and it releases that energy. So like that's what makes it a combustion reaction, is that carbon dioxide and water are in the product, and you have like a fuel reacting with oxygen in the reactant. So an example of a combustion reaction is when the paraffin wax in a candle plus oxygen react in a combustion reaction, which produces carbon dioxide and water vapor. It is an exothermic reaction. So you can see that chemical equation down there. Notice, well, it's a very big hydrocarbon, reacts with the oxygen in the air, and the products are carbon dioxide and water, and it releases that energy. So at this time, I'll go ahead and give you that verbal code. The verbal code is 005. I say that again, the verbal code is 005. All right, so this week there was we did a class activity that basically just went over this. Hey, what makes this reaction, this type of reaction, this type of reaction, and identifying those chemical reaction models. And this is a good way to get practice with that. And this video helps out with that. All right. So just as a final thought, remember there's too much unknown in the universe to take a break from learning. Get out there and question everything.